Good afternoon, everybody. As stated, my name is Paul Clayton. I'm the general manager of the OEM division at FLIR. The discussion today is thermal cameras to improve autonomous driving and safety. I'm very excited to speak today because our mission at FLIR is to save lives and livelihoods by utilizing sensor technology for improved awareness. All right, and this is exactly what thermal technology can do. I'm going to talk today with some fellow partners that we're working with on this topic. So you guys come up on the stage, please. So we have Rudy, Walter, and Christoff, and I'm going to let you guys introduce yourself. Okay. Go ahead, Rudy.
So, am I live? Good. Hi, I'm Rudy Berger. I'm the managing partner of an investment bank called Woodside Capital. We're based in Palo Alto and London. And we do mergers and acquisitions in a number of technology sectors. We're very active in the autonomous mobility sector, including all of the sensor modalities, technologies that roll up into these vehicles.
Great. My name is Walter Hern. I'm with ANSYS. I run the Americas. And what we do at ANSYS is we simulate products. One of the biggest challenges we're seeing with companies is the amount of time you have to develop a physical product and test it, right? It's all bound by the amount of time and money you have. And what we do at ANSYS is we enable companies to simulate their products virtually, right? So you can test all different variations in a computer and test thousands of variations so you can come up with a much more improved product in a shorter time period.
Hello everybody, my name is Christoff Buettner. I work for the company Veoneer, which was in 2018 a branch of the company Autoliv. At Veoneer we focus really on sensors, systems and solutions for advanced driver assistance and autonomous driving. Together with a joint venture that's called Zenuity that Veoneer has together with Volvo. And there we develop a software as a drive stack that can drive partially autonomous or fully autonomous in the end. And we're focusing on various types of sensor solutions and software behind it to make these sensors to a feature and a usable system for the car driver. Yeah.
Okay, so the reason we're speaking here today is, like I said, FLIR's mission is to save lives. And one of the key concerns we have is the fact that even though, as you can see here, traffic deaths are decreasing year over year, pedestrian accidents are actually increasing year over year. That's a problem. Cars are supposed to be getting safer, but apparently we're killing more people on the road. So, Christoff, you know a little bit more about this than most because you've been in the business for a long time. Do you want to give a little bit more flavor to this particular topic here?
Yeah, I mean, what we see on this recent traffic data from the US is basically that when you look at the details, the most pedestrians are killed in darkness. And this number is raising, even though we put more of these advanced systems, warning and intervention systems on the market, like a braking system or a pedestrian accident warning system. So it means that basically, nevertheless, these systems have some weaknesses. They work probably, and they're mostly tested during daylight, and they have some weaknesses during nighttime. There should be other factors also. I mean, you can think about people being distracted while driving. They look at their smartphone or play with the entertainment system of the car. That may be also another factor. But nevertheless, this number is something that's alarming, and I think we together here can talk about a potential solution for that. Yeah.
Yeah, I think as we come to rely more and more on these so-called safety systems, people are thinking the car's going to stop or the car's going to take effect. And we rely on that. Now, how can thermal help? If you're familiar, you've walked the booth, you understand what thermal does, but it's a different part of the electromagnetic spectrum. So we don't look at light like a regular camera. We look at heat. Everything gives off heat. So we don't need any illumination. We work really well in multiple conditions. One of the ones you're seeing here, and I'm probably sitting in the way here, but yes. If you take a look at this video, one of the things you may come across driving a car is fog. Not that often, unless you're living in San Francisco, but nevertheless, you get fog. Now you can see as you're driving down, there's a visible camera here to the left, the thermal camera is to the right, and you really don't see the fog because the thermal camera is not relying on any illumination at all. It's only relying on heat. And this thing's looping, so you might see the pedestrian right next to the lamppost there, pops out from a cluttered environment. You drive a little bit further, there's some people walking along lampposts and trees. Again, the people pop out immediately in this environment. So thermal can add benefit over and above the visible camera. So if you go to the next one, the other thing that you can see is sun and headlight glare. How many people have driven down the road and squinted and dropped the sun visor? You get a similar effect in your cameras, and even to a certain extent, LiDAR can be blinded sometimes by the sun. They're working on it, but we have a solution in place today. You see a little bit of the sun because it's a hot object, but you don't get that glare that you'll see in a visible camera. So this is something that happens a little bit more often than fog. And then the next thing you see is shadows. This example is coming into a tunnel. If you notice, as it drives in the tunnel, you can see all the cars. It's dramatic. We have a tunnel up near Santa Barbara where I'm located. It's actually, you're allowed to ride bikes on the 101 through it, and it warns you with a sign outside, careful, don't hit the dude on a bicycle. But you can't see the dude on a bicycle. You're going in and you all of a sudden you're blinded and it's dark. We can see that clearly, okay? And the last one, which you'll see a lot more often, is darkness. Unless you're north of the Arctic Circle, you're going to get it, every night. This is actually something we did. Unfortunately, we reproduced the accident that was in Tempe, Arizona. It was a Uber accident. This was interesting, the fact that we used some of our analytics. So we not only have the thermal camera capability, but we're also working on analytics. How do you classify and detect these people? And you can see here, when we tested this, we saw the person that was occluded by the bicycle a full 10 seconds, and you can see this in the visible versus the thermal camera. And again, you pop out of that cluttered environment. So the ability to reduce deaths using this technology is actually pretty substantial. We have actually been FLIR in the automotive market for over a decade. It's a little known fact. I think it's a well-known secret. But we've been partnering with Autoliv and now Veoneer. So Christoff, I'd like to talk to you a little bit, you to talk a little bit about the history of thermal in cars, if you don't mind.
Yeah, so when it was first introduced as a system to give the driver the possibility to see through the darkness, it was really back in 2000. It was the first car ever that had a so-called night vision system based on infrared technology. And in 2005 is basically when Autoliv and FLIR together came out with the first system which was launched globally on BMWs, and is still kind of an option on these cars today. We have since then penetrated a number of other customers with this solution, amongst them the German brands, but now recently also added GM as one of our customers, and also notably PSA in Europe. So we have a good track record as far as penetrating these OEMs with the system, and the system is being offered today mostly on the let's say upper or luxury segment of these product lines, because of the pricing that was initially established, and now it seems like the option pricing is not coming down, even though between our partner FLIR and ourselves we have reduced our pricing. So unfortunately there's not a lot of movement in the option pricing. So that's a little bit something we have to overcome in order to make it more popular, because there's a certain level of dollar amount that people are willing to spend for such a feature. Yeah.
So there's a dollar amount that we're trying to hit. Yeah, exactly. Before I go to this slide, there was one other thing. You had L4 with a bullet at the end there. I'd like you to talk a little bit about what exactly the L4 means in that slide, if you don't mind.
Yeah. So if you could go back to the previous chart, we have been penetrating the OEMs as far as the personal vehicles, but lately we have been awarded for a level 4 robotaxi, which is produced by a major international OEM. So we're very happy to see that this L4 segment, which is really looking for autonomous driving and is using all the different sensor modalities to get a good perception of what is happening around the car, is also finally adopted the far infrared. So that's for us a key event, and I can tell that, and I mean you can complement this, that a number of other companies are also looking into that, but not officially announced. Yeah.
And it's full level 4, and you said a major OEM, right? Any hints on who the major OEM is?
No, we cannot talk about it.
Okay,
now.
that's
At some point we will.
That's too bad. Hopefully we'll be able to talk about that soon.
Yeah,
so,
next
all
year.
right, and then when you talk about night vision, a lot of people are actually not that aware of it, but here we have a chart that states that night vision is extremely desirable. You guys put this information together, so can you talk through a little bit?
Yeah, it's actually, the source is IHS, so it's a credible market research company. And they ask buyers of the intention of what kind of features they want to put on new cars. And so they give them, I don't know, 50 or 80 different options and ask them, hey, what is your intent to have on the next car? And you can see that this is only the top 5 of the 80, but number 2 is a night vision system. And they give an explanation what a night vision system is and what a blind spot detection is, and so that they understand what the feature does. So that's really, for us, a very, very good indicator that in the public awareness or in the desire of consumers, there's an interest for this feature. But nevertheless, if you would do the same chart and ask for the willingness to pay, the willingness to pay is probably below what we see in the price segment today. So that's one of the problems. So there's a lot of interest, but there's not really the right price point at this point.
Right, thermal still is quite an expensive technology compared to a lot of visible cameras. So
like a normal
that's
CMOS,
the concern, right? Correct.
Yeah,
okay.
that's part of it.
All right. And then when it comes to the desirability, we mentioned that we have a lot of OEMs interested. Christoff showed that. We have a lot of desirability. But then there's how do you get that in a timely manner to market? So Walt, we're partnered with ANSYS on simulation. Can you just tell me a little bit exactly what do you mean by simulation to help people out?
Yeah, so I think you guys did a good job, and we've been on this autonomous journey in the automotive industry for quite a while. And you guys identified some of the failure modes, right? Fog, nighttime driving, and historically how we've been identifying those is driving the cars on the road. There's a great study that came out by RAND that said, look, we're going to have to drive 275 million miles to identify these fault-free miles. And if you look at the top companies, Waymo, they're driving only a couple million miles a year. So that's been a really big barrier to getting to full autonomy is driving these physical miles. And so at ANSYS, what we're doing is we're enabling companies to simulate these miles virtually, right? And so FLIR early on recognized that to validate their systems, if they could do it in a virtual environment, they could get their cameras to market much faster, right? And so in a virtual environment, we can test how the camera performs with the fog, how the camera performs under solar glare, and we can test all of these different variations virtually. So rather than waiting 20 or 30 years to test it on the road, we can do it in a virtual environment. And so ANSYS and FLIR came together to enable our customers and FLIR to do this.
And is like a gaming simulation? How's it differ? How do you differ from like the gaming system?
Yeah, so you if you walk around, you probably see a lot of gaming engines where you see these beautiful pictures and you see these cars driving down the road. Now the difference between ANSYS and that is we're coming at it from a physics-based perspective. So what does that mean? That means we're actually adding the material properties to the scene. So we're actually solving how the camera interacts with the fog, how the camera interacts with snow, rain, all of the different environmental conditions. And because ANSYS has been a physics-based company for a long time, we have that functionality and that capability. So we can bring that into an environment. Not only is it testing the performance of the sensor, but another key component is developing the perception algorithms, right? We have to develop robust perception algorithms to identify the objects. And FLIR's working on that. And if we have a physics-based model, we're able to develop these next-generation algorithms in a much faster pace than actually driving the cars around the road.
Yeah, so it was interesting working with ANSYS because you really do have to put the physical model of the sensor into the simulation package. So you have to really understand the physics of your sensor in order for it to work in their environment. It's been actually a fun program to work on you guys with that. Yeah. So thank you. All right, so we talked about the fact that we can do things with thermal in an automotive safety standpoint. People want it. We're simulating it. Now we have this standard called AEB coming in 2022. And NCAP, all the insurance people are saying, if you can put this in, it's kind of mandatory in Europe, it's optional in the US. Really, just a little bit, there's a lot of investment in autonomous vehicles and ADAS, advanced driver assistance systems. Can you talk a little bit about where that investment's going and how are people going to get their money back? We hear a lot of hype about autonomous vehicles hitting the market this year and then it doesn't happen, then it's next year. What's going on with the investment and the return here?
Yeah, I mean, it's been very interesting to look at the numbers. Just to give you a snapshot, I checked before I came over here. Last year was about $4.5 billion invested into exterior automotive sensing. So I'm not talking about heat, humidity sensors to turn on your windscreen wipers. I'm basically talking about radar, LiDAR, and vision companies. $4.5 billion. And over 100 LiDAR companies have been spun up over the last few years. So all of this investment, from my perspective, is quite a bit ahead of market reality. But even more interesting is that thermal imaging has really hardly had a look in. Thermal imaging can do something that is actually quite complex with LiDAR, radar cameras, which is to almost instantaneously determine whether there's something alive in the field of view. It's quite complicated to do that with other imaging modalities. So I believe that there both is a role for thermal in the evolving ADAS market, which I think we should all be a little more focused on than autonomous vehicles. But for various reasons, it has been a dark horse, and it's interesting to me as to why it's taken as long as it has for adoption of thermal imaging into automotive.
Just recently, AAA did a study. They threw a Honda, a Toyota, a Tesla, and a Chevy with the latest AEB technology and did some testing. And it was kind of dramatic. Christoff, you're probably a little bit more familiar about this. Do you want to talk about some of the results here?
Yeah, I mean, the findings of the AAA was basically that these systems supposedly are AEB systems to prevent accidents with pedestrians. And during daylight, they work more or less properly, not catching all the scenarios that were tested, but most of them. But at night, there was a complete blackout, if you want, right? So usually there is a warning stage, and then there's an intervention stage. And during day, the warning came up, and then the intervention came, so the car came to an automatic braking mode, and most of the time was able to stop in front of the pedestrian. But at night, there was not even a warning. So the cars were just basically barely with full speed driving into the small puppet that's up there on the street, which is something that the AAA pointed out and said, this is not acceptable, especially in the light of the fact that the number of pedestrian fatalities or accidents are going up. I know that in Japan and also in Europe, the NCAP regulation or the NCAP association already is looking more into nighttime accidents. So they're already, highlighting the fact that the system should also solve these issues or solve these cases at low visibility. I hope that something like this will also come up in the US.
Yeah.
Yeah, so just to recap the very first slide, 6,000, I think, fatalities in America, pedestrian fatalities. 75% of those happen at night. And AEB is supposed to stop hitting people, but 75% of those accidents are happening at night. So we're going to show you the video. This is available online at AAA. It's on YouTube. It's a little bit shocking. Luckily, it's only dummies. But let's just roll the video and we can see it.
It's coming. Yeah.
There's no sound effects, which is a good thing.
Yeah.
So these are some corner cases. The car's turning right and the pedestrian's walking. What we've done recently is we've taken a vehicle just like the one you see over here. We put our thermal camera on it and we fused it with the radar, which is how AEB typically works in all of these systems. And we went to a proving grounds and we did our own testing. And we got really good results. It's not surprising we work well in daylight because the sensor will work in daylight as well as nighttime. So it'll work just as good as a visible sensor. But at night, it was dramatic. In the testing we've done so far, we've had 100% success because that's what thermal does. It sees heat. These are heated dummies. They're reproducing the fact that people give off heat. And so 100%. So we're actually excited that our mission to save lives and livelihoods can be very well fulfilled using this technology. We're going to work with AAA and IAHS and get back in front of these guys because we think we can save thousands of people a year just in the U.S. alone. So we're excited. We're excited to partner with all you guys to bring this to market as soon as possible to get this solution out there. There's a cost to a human life. What wasn't said or seen in this, it was 90% of the time a child was hit in daylight just because they're small and not a lot of radar signal. So just think about that if you're a parent. What cost would you put on your child crossing the road? Makes you think. Anyway, so I appreciate working with you guys in the future on this so we can bring this solution to market. That's it right now, but we're more than happy to take questions from the audience.
What is the cost relative to LiDAR, and can it fully replace LiDAR?
Okay, so the question is, what is the cost relative to LiDAR, and can it fully replace LiDAR? I'm going to take a whack at this. I'm going to let Christoff have another whack at this as well. I don't think thermal is going to replace LiDAR. I think LiDAR has certain benefits. I think LiDAR is a really good ranging system and gives you some situational awareness. But at speed and at distance, to get points on target is very difficult. I think radar is also a very good ranging system, but has resolution concerns. I think thermal complements visible in the classification and detection of live things in any lighting conditions. So I think it completes the whole sensor suite. When it comes to cost, when this thing came out years ago, it was thousands of dollars. We brought that cost down to where in automotive volume, we're thinking a couple $100, which is very achievable and right in the sweet spot where automotive makers are thinking they've got to be. Christoff, do you have any more flavor to that?
Yeah, I mean, I would completely support your statement that the far infrared sensor will never replace a LiDAR. I mean, that's not. It's also not our intention. As I described earlier, we are sourced for a level 4 program where, aside from camera technology, radar technology, and LiDAR technology, this OEM choose to put also a far infrared technology. And I can talk that much about the fact that we're working with other companies, but also we are active in the trucking area. The autonomous truck is a very imminent thing that will be coming on the streets, and also there far infrared is under consideration. So I think as you said, each sensor has its strong points and its weaknesses. But the point is you need as many sensors on the car as you are able to complete the sensor spectrum to have at least 2 sensors under each condition confirming the object. And that's the key. And again, it's not a competition between the sensing technologies. It's really we should help each other, rather than trying to compete.
Right.
Another interesting way to look at that as well is a lot of people are trying to get high resolution LiDAR that'll look far down the road and give you good situational awareness. And you may be able to reduce the overall system cost by including a thermal camera to where you don't need to rely on the LiDAR as much moving forwards. So if you take a look at holistically the entire sensor suite, it may be more economical to add a thermal than it is to go for a high-res LiDAR. So just a thought. Yeah.
Yep.
All right, any other questions?
As far as hardware concerns, the processing power, will we need more modules to, again, validate what the cameras and LiDAR are seeing? Kind of talk to a little bit more about the processing needs of thermal imaging.
Yes, so far the thermal sensing has comparatively low resolution to a CMOS, and it's only black and white and not color. So the processing power for the image extraction steps is not so big. We really would like to see working together actually on the simulated data, because you can imagine there are certain scenarios where you don't want to put a pedestrian closely in front of a car to kind of test if your system works. It's better if you simulate that, especially corner cases with specific weather or lighting conditions, which you find not so often. It's very helpful to have simulated data. We do that in radar development together. We do that in vision technology already. So it's a proven thing. We will definitely do that also for our thermal sensing sensor set. So I think the computational power is not a big issue. I think it's solvable.
It's very similar to a visible camera.
Yeah.
So it's just like adding another visible camera to your sensor suite. It's the equivalent.
Can you speak to the robustness of the hardware? Like, is it sensitive to cold or to heat or to vibration or?
Sure. We've been automotive qualified at FLIR. We put over 700,000 sensors on the road since 2003?
Five together.
5?
Yeah.
2005.
Well, yeah. In production, 2005. Yeah.
The latest version, Night Vision 3, we've shipped hundreds of thousands of those, and I don't think we've had one field return. They're extremely reliable. Part of the thing that when we partnered with Autoliv at the time, we thought we were a very high quality thermal provider. They brought in automotive quality as a requirement over a decade ago, and we've been internalizing that. So we understand what automotive quality means, and we've had that in place for over a decade, and it's something we continually ratchet up and improve on. So we talk about parts million failure when it comes to automotive, and so far we've been extremely good at hitting that target.
Yeah.
Any other questions? We're a few minutes early, but I will let you guys go. So appreciate all the attention. And again, spread the word. Thermal is going to be really good to help save lives and livelihoods. And we're excited to be in the market space. And we're excited to sell more cameras into this and help people save lives. Thank you very much for your time.
Thank you.